Here's an application problem for a quadratic function. This is example 1. The highway mileage M in miles per gallon for a compact car is approximately M of S equals negative 0.03 S squared plus 2.4 S minus 30, where the variable S is the speed in miles per hour. And then the M represents the miles per gallon. So if you think about this as a quadratic function, like f of x equals negative 0.03 x squared plus 2.4 x minus 30. We've just changed the variables to m's and s's. So step 1, I'm going to just show you how this graph looks with a graphing calculator. I've set up my coordinate plane. My x-axis represents my speed. My y-axis represents my miles per gallon. And I'm going to enter into the graphing calculator this piece. Let's go off to the side here. I've entered it in already, and I'll show you how to do this in class. What this graph looks like is a parabola. That is right here. And it opens down. So I'm going to just push some buttons on this graphing calculator to show you what some ordered pairs look like. So I'm going to push this trace button. And notice this ordered pair pops up and it's blinking 30, 15. I'm just going to go to the arrow key to the right a little bit. And I'm going to the top of that hill, the parabola. That top of that hill looks like it's about 40 and then 17, or 40 and 18. That's the maximum for x and y. I can then scroll down here. You'll notice the cursor is moving. I have an x-intercept at about 15. I can scroll down more. My y-intercept is about negative 30. I can scroll back up and just watch my cursor go. So if I take the time to graph this, just a quick sketch of it. It looks like this. Here is 0, negative 30. This maximum point of 40, comma 18. And then it scrolls back down here. I use my arrow key. About 52, 53. Right here is a x-intercept. All right, so this is just a rough sketch using that graphing calculator. What we're going to do instead in our homework is the step 2 and 3. But I wanted you to get a visualization. So what we're going to ask you today is, where is the maximum point on the graph, the vertex? So with the graphing calculator, we think it's about 40, 18, this vertex point, this maximum point on the graph. Probably here. We're estimating it with the graphing calculator. I'm going to show you how to do this with that formula that we learned, opposite of b over 2a. So to find the maximum, we say x equals negative b over 2a. So here is our a, and here's our b. So our a term is negative 0.03, and our b term is 2.4. We're going to use that formula. Opposite of b, so negative 2.4 over 2 times negative 0.03. Now we're going to use our calculator. 2 times 0.03 with a negative. Negative 0.06. And then negative 2.4. So negative 2.4 divided by negative 0.06 is 40. Did that show up on our graph for our x value? Yes. Now to find that 18, which we think it's 18, we evaluate the function. We say f of 40, and we'll get out that vertex. So I've kind of run out of room here. So I'm going to back up into my function, and I'm going to evaluate it. So f of 40, replace the x, or s, with 40. Replace the x with 40, and simplify it. So 40 times 40 is 1600, times negative 0.03 is negative 48. 2.4 times 40 is plus 96, and then minus 30. Negative 48 plus 96 minus 30 is 18. Go up to our graph. With our graphing calculator, we traced that we thought that vertex y value maximum was at 18. So now our vertex is 40, 18. What does this mean for our word problem? What is the maximum mileage for this compact car? That's going to be your y value, or your m. So what is our y value for our vertex? 18. So our maximum mileage for this compact car is 18. What is the speed results of this mileage? So that's your x value, 40. So that's your maximum speed when you have 18 miles per gallon.